Hi, my name is Scott from the Economics Tutoring Center, and today we're going to be talking about how to construct a confidence interval. Please make sure to check my notation and language use with your professor because it may vary. So, a confidence interval is a range of values that if you take a sample, you expect the mean to be within that range with a certain level of confidence. So, there's a formula for it, and you start with a point estimate of your population mean, so x bar is a sample mean, and you plus or minus a certain margin of error, which is this term here. So if you know your population standard deviation, you want to use this first formula because it has sigma in it. If you don't know your population standard deviation, you'll have to use a sample standard deviation and use this formula with the t-value. Here's some of my notation for these formulas. And basically like I said, what the confidence interval does is you take the margin of error, which is either one of these two terms, depending on whether or not you know the population standard deviation, and it constructs an interval like this. In the center of the interval is your sample mean, x bar. You add the margin of error to get the upper limit of the interval, and you subtract the margin of error to get the lower limit. This entire interval is where you expect a sample mean to lie. So now we're going to look at one example of how to construct a confidence interval. And here's our question. Assume a population has a known standard deviation of 12. Construct a 95% confidence interval for the sample mean, given a sample of 64 individuals with a mean of 70. So the first thing we're given is that we have a known standard deviation of 12, and the fact that the standard deviation is known tells us it's a population standard deviation, so sigma is 12. We also have that we're doing a 95% confidence interval, so our confidence coefficient is 0.95. We have a sample mean was 70, so x bar is 70. Our sample size is 64, so n is 64. So if you remember our formula, we have our confidence interval is x bar plus or minus our critical z value, and we're using the z formula because our population standard deviation is known, times sigma divided by the square root of n. So the only thing we're missing now to be able to use our formula is the critical z-score, and this is usually where the most work comes in when building a confidence interval. So to find that, we have, so we're trying to find z sub alpha over 2. That just means it's our critical z-score. We know our confidence coefficient from before is 0.95. So remember, to find alpha, alpha equals 1 minus the confidence coefficient, so our alpha is 0.05, and if we divide that by 2, we get 0.025. Now the way you find your critical z-score given your alpha is by looking at the z-table. So we need to find this probability of 0.025 on the z-table, which will work if you have a table of negative z-scores. If you don't have a table of negative z-scores, then, and you just have positive z-scores, then we have our z distribution looks like this. We have 0.025 on either side because that's our alpha over 2. So if you can find everything besides 0.025 in your z-table, that will give you the positive z-value. So it's the same thing. And that value, 1 minus 0.025, is 0.975. If you look on your z-table, find that probability in there, you will find that the critical z-score is 1.96. So now we have everything we need for our formula, which was confidence interval is x bar plus or minus our critical z-score times sigma over square root of n. So if we remember, our x bar was 70, our critical z-score we just found was 1.96, our sigma was 12, and n was 64. So then if you type these into your calculator, you will get, for your upper limit, by doing the addition, you will get 72.94, and for your lower limit, you will get 67.06. So what does this tell us? It says, with 95% confidence, you would expect a sample mean to be within that interval. So it's between the lower limit first, 67.06 and 72.94. So that's what a confidence interval tells you, and that's how to calculate it with a z-score. Using a t-score, it's a little different. You just have to use the t-table, but otherwise it's the same. So I hope this example helped. Alright, so that's all we had today about confidence intervals. If you have any further questions, please feel free to come into the tutoring center or ask your professor.